on to the movies and things like that. So
What about
I
the
have a
flood?
giant screen in front of me.
What about the floods?
So we're in the south side of Jersey, and it wasn't that much affected, mostly the north side, but also the Philly, uh, uh, Philadelphia was hit pretty badly, but we didn't see much, thankfully. So yeah. So hey everybody. So I'm super happy to um, lead this meeting today in putting Dennis Rothman on the spot. And I remember pitching this idea of bringing Denis in because simply because Denis said something that caught my attention and I wanted to know more. Um, I don't know if you remember, Denis, but you mentioned in one of your uh, sessions here, you were present with us, and you said there is this trick that you use that you could help us learn this trick as well when you're going through papers, research papers,
Yeah, yeah.
and you can cut that time by half or even more and absorb the essence of this paper, how to truncate it, how to kind of skim it, extract the value of it, and make sense of it and move on to the next paper. I think this is a skill that all of us should have because there are so many materials out there, so many documents to read, so many books that time is probably the best commodity or the most valuable commodity. So with that, Denis, and there are some other questions too that I have for you with regards to a series of posts that you've issued on LinkedIn that are super interesting, especially the meta language of GPT models. Those are the things that I'd love to explore with you today.
Sure. So you want me? I can share my screen, in fact, because I opened an article, and then this way I can bring you through my thought process. Do you see the article?
We can.
Okay. Now, this is my approach. I'm not saying it's the approach, so I'll just pretend you're not there, and I'll just do it like I do when I'm alone. Okay. So I look at the title. I looked at the title here. Of course, I'm in slow motion because I'm describing it. Usually I'm in fast. So I look at the title and I say, wow, this is a title of a Beatles song. All you need is love. Da-ba-da-dum. Because if you're not having fun, well, don't read the papers. I mean, so my thing is, I was saying, all you need is love. Boom, 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 boom. So all of a sudden, there's a new dimension here. It's love is all you need. So love is very important. So that means that attention, maybe there's a Beatle fan that, that thought of that. And I'm saying, wow, for him, this is the key word. This is the key word of his article will be attention. So even before I start reading the article, I know it's attention. Then I see it's Google. So Google is really into a lot of hip music and all that. So I would say they probably someone was having fun in there. Okay, so then I go down. So now I know that attention is the main thing I have to look for. So I'm in slow motion. So now the abstract for me is this very important because generally these writers are very good and they can squeeze everything into their abstract very, very well. They work together. See, like they're like 2, 4, 6, 7, 8 people writing this. 1 or 2 of which don't have a college degree, by the way. In fact, the one that wrote the most here doesn't have a college degree. So it tells you. So then I want to read the thing. So I see the word transduction. Okay. Now, for me, transduction is an extremely important concept. I mean, that's I'm speaking about me, I don't know about it, but for me, that is because there's a person in France called Simondon, and he wrote about genetic transduction. So it's transduction is it just hits your mind because you go back to recurrent neural networks, but transduction means you're going to transfer concepts from one place to another. So now they got my attention. Attention, transduction. My mind's beginning to flow. Encoder, decoder. Well, okay, that's easy. Even when you're playing when you make Morse code or anything, it's very easy to understand encoder, decoder. So somewhere there's going to be messages, they're going to be encoded and decoded. There's attention somewhere and there's transduction. So it's these guys, I'm saying these guys are powerful. So I don't read this sentence. For example, I'll tell you, I didn't read that sentence. There's nothing in here. So, because I have attention already. So my mind flows like that. If there's nothing new, I'm so used to, I don't even look at the sentence, blah, 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 up. So being parallel. So if I was in slow motion, this is like 1 second. Since I have the big stopper for me was the title, then transduction, encoder, decoder. Okay, so there's going to be encoder, decoder, and attention. Parallelizable. Now that is something, that's a stopper. That's a stopper, a complete stopper for me. So you see, in 3 words, I'm finished. I'm almost finished here because there's attention. That's all you need. It's going to be parallelizable. There's going to be an encoder, decoder, and there's transduction. Well, okay, I have the picture already. It's over. For me, it's game over. The rest of what they wrote here is okay. We improved the results and blah 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 blah. So, not interested. This is my first reading. A second or third time, generally I'll print it out on a piece of paper and I'll read every single word. Okay, but that's just for fun, listening to music. But first, I want to get into the paper. I don't want the paper to get into me. I don't want it to dominate me. I'm dominating the paper. So right here, I know that I have attention with encoder decoders. There's transduction and parallelizable. That is something that's an eye catcher. This is the key word of the whole article. In fact, is parallelizable. Because in fact, so we don't know it yet. So let's go. So that stopped me. Blah 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 blah. That's recurrent neural networks. Blah 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 blah. So recurrent, position. Blah 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 blah. You're in my brain. So blah 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 blah. So now here we go. Attentions, intro attention. I don't see anything new here for the moment. So blah 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 blah. Okay, now model architecture. So now I'm 3 or 4 seconds after I open the PDF. I'm looking for attention, parallelizable stuff with transduction, encoders, decoders. Okay. I'm not saying I'm normal, Greg. I didn't tell you, but I come every Saturday from a hospital where they let me out for 2 hours. Okay, so now I'm puzzled. Here, I'm very puzzled here because now I have this continuous representation, the decoder, the autoregressive.
Dennis, you shouldn't make fun of my actual state of life. That was unkind.
Yeah, but we go to the same hospital. You're Napoleon and I'm Caesar. Okay, so right here, really, okay, a continuous representation. It gives I'm not getting very much information out of this paragraph. I'll come to the art. I want to understand what's going on after I'll print the article, but first I need to know if this is interesting or not interesting. So now, whoa. Now this one here is so you see here, when I saw that, I'd say, whoa, this is really something. Because now I have 6 identical layers. Wow, that is mighty impressive. Because I'm wasting so much time on these CNNs with all kinds of layers and this filter and this size and dense and not dense and pooling And wow, 6 identical layers. Wow. And multi-head attention. So now I know they're going to parallelize. It's going to be parallelizable right here, multi-head. They're taking the attention, bing, 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 bing. They're dividing it into several heads, and all the layers are the same. So I'm saying, whoa, this is Manhattan. This is a building that's going to be built in blocks. It's not going to be different size layers, and here you get 3,000 per. No, it's everything. It's building blocks. So I'm saying, wow, this is a revolution. This is something I haven't seen in 30 years. Because honestly, I'm bored to death with people saying something's new. It's just something old that they just wrote in a new way. This is really different, okay? So I'm saying, okay, 6 identical layers. They have 512 features, okay? And then this layer norm or the sublayers and a sublayers, I go back here, and now I'm puzzled by all this. I'm puzzled, but I trust the people. I say, well, positional encoding is not even included in the embedding. So now I'm very puzzled. I'm puzzled, but I don't want the paper to get onto me. So I want to go on and see what's going on. The decoder is the same. So now we have this very, very structured system with attention, identical layers, parallelized multi-head attention. Well, that looks cool. And then they give it's matrix multiplication. And then, oh, that's all there's in there? There's nothing in there. It's just three sets of weights. And it looks exactly like SQL. It's funny because SQL, I make a query, I hit the keys, and I get values. Now here I want to divide this by this because we're used to normalization in our job. So I'm saying, wow, it's so simple. These guys, they're geniuses because I love simplicity. So I'm saying, wow, I'm only here. I got it. They took attention. The thing is, they've done away with recurrent networks. They have attention. They divided it into 8 parts in parallel processing, which will go to probably 8 GPUs. And they just made this function here with 3 weights that the system will learn. And all the layers are the same. This is genius because I've seen 30 years of stuff you don't even understand. The recurrent neural network, and then you have this short-term, long-term memory, and then it's wow, this, you can explain this to a first-year college student. Even see, you have a query with SQL, query, key, value, just mix it all up with weights, divide it into 8 parts in attention. It's interesting. So then they go back to multi-head. So now this is funny. Because now they took the 8 heads, but they're not adding them. It's concatenation. They're just putting them next to each other. They're putting it back together again. That's strange. So it's like cutting a piece of cake and then putting the cake back together again. And we're not used to that in artificial in deep learning. And usually we add things up. No, they're keeping it separate. So it's making, in fact, 8 different ways of looking at stuff. So then basically that's it. Forward, forward, blah, 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 blah. And I don't care about translation because they're trying to prove something to someone, but I don't need anyone to prove anything. So now I know that I faced a revolution. So I would say this took me like 1 minute. If we sum it up the first time, all you need is love, bum, 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 transduction, encoder, decoder. Okay, break it up into 8 different heads. Okay, 6 identical layers. Okay, after that, put it in this little formula, put it together. Wow, I mean, impressive. So once I've done that, then I print the article. and I wait a couple of days. Because our brain works by itself. So now I put some it's in the ingredients of a meal. I put the ingredients of a recipe in my brain with very few concepts. And for a few days, it's like, it's obsessive. They're going to begin to mix up with each other, and it's going to reach maturity by itself. So after a few days, what looks so big looks very small. I mean, it's just attention, 8 heads. Once you're finished, you put them all together again. You have a forward feed network, identical layers. I don't want to test programs. I don't want to do anything. I'm waiting 2 or 3 days. Then I'll come back and I print it. And when I print it, since you can see I get bored reading very quickly, generally I'll print it and I'll read it while I'm watching TV on the couch. I don't want to be bothered by this article. So I'm going to be in my couch watching a nice, I don't know, an action movie with Jason Statham or something that's my intellectual level, Steven Seagal, things that satisfy my intellect, which is, so it keeps the cooling. It's a cooling system. I'm watching television, so it's a cooling system, so my brain doesn't get overheated. So I begin to read it word by word now. So word by word, I look at all the words and I have this highlight. When I don't understand something, I just highlight it. Like, where does this double WMT come from? Why did they say that? Why are they using this? And I'll go on. I'll even go there and I'll just highlight words I don't understand or acronyms or stuff like that, and put the paper back again. And I'm just going to focus on the words I didn't know or the stuff I didn't understand. And then I'm going to go look on internet to see what other people were thinking. But the thing is, when I wrote that one, there was no one on the internet. So I was all by myself. I didn't have anybody. So I was saying, uh-oh, there's a problem here. There's no one. I'm all alone. Please help me. But no one can help me. So then I just read it, word by word. And then after I tried to do it in Excel. I just made this little thing. I just play around with it I just play around with it after. I just play around with the concepts. And then I went and got a model. I went and got a transformer model. I started looking at Google Tracks, Google this, Google that, Hugging Face, and all that stuff. And that's about it, and then what I do is I go quickly, as you said, but I'll come back to it every several days and I'll let this, my body catch up. It's something very physical. So I let my body catch up. Sometimes I might drink a glass of wine, with a piece of cheese. And, I always need a cooling system. I can't just stick in that dry stuff. There has to be, or my soup, or there has to be something physical. I'm watching a movie. I'm eating some stuff. And I'm listening to music. Sometimes, since I play music, I'll put it where you put the music scores, and I'll play some jazz looking at the stuff. I need a cooling system. So basically, that's how my mind works. And then after I go into the programs and I try to build stuff from scratch, and then I go deep and deep and deeper and deeper and deeper and deeper and deeper and deeper until I understand every single word, the address where this conference, I go in autistic mode until I have every single detail, but I just zoom down very quietly and I'm in no hurry. And since I'm in no hurry, my brain is okay. So all this happened in a few hours, the first time I saw it, because since I'm letting my brain relax, I'm saying I take a few days, but then I wake up at 1 a.m, I come back. So let's say that in less than a week, I was finished with this. I had my book ready in my mind. I knew the chapters I was going to write. And I wrote the book in 2 months and a half.
That's
2 months and a half finished.
That's pretty interesting. I loved how you walked us through what's going on in your mind. I do have some follow-up questions, but I know the audience also is eager to ask you a few things. I know Tom raised his hands before. So Tom, do you have some questions for Dennis? And then I know Manpreet has a question in the slide. Then I'll go to Rife. You're muted, Tom.
Thank you.
Yep.
So, Dennis, I want to just go back what I learned from you just now and see if I've got it right. The first thing, and I put a little Tommy's into this too. So, first thing on the title and abstract, going ahead and really understand every word, every keyword in them very carefully.
Yes.
And then expand your understanding using dictionaries and other such resources when it seems like it's an important word and you don't really know it.
Yeah.
Then gain appreciation of the keywords. Oh, I just said that. Sorry. Now, also, I kind of added this. This was like reading between your statements, but what are the foundations of this paper? Try to appreciate why it's a big deal. Like, I agree with you. I hated learning recurrent neural networks and the other kind. And I like CNNs, but I kind of saw CNNs as being an inspiration to this. Hey, how can we take CNNs to the next level? So I did appreciate some of the foundations of this paper, but also some of the pain points that motivated transformers. So just an idea of really trying to get a feel for why it's a necessary paper. And that might even caution you, this isn't an important paper. Why are you wasting your time on it? And this is what I liked the most. Don't go too deep on the math mechanics and on the overall understanding the paper out of the gate. In other words, on your first pass, you're trying to get a very high level appreciation of this paper. So just appreciate it initially at a high level, but with each of your multiple passes, go a little deeper brain reach each time.
That's right. That's what I do.
And then if important enough to you at this point, print it out, mark it up, just so you can carry it around. I hate paper, by the way, but I still find huge value from it as a rapid thing and being able to draw notes on it. So I love that.
Paper, yeah, paper is very important if it's a good article, because usually I'll take it to bed, and before I go to sleep, I'll read the key points again and I'll daydream on them. I just daydream. I'm dreaming of what it can do. And then when I go to sleep, I know that, in the morning, things, are even clearer. So you're right to carry it around. And in bed, it's less intrusive if you're in bed with somebody and come with your laptop, since the other person's reading a book. Well, you're just reading your little paper. It's not intrusive.
But you can put it on a tablet too. But I like the idea of the paper, especially if it's on a clipboard, then I can write notes to myself. And then the last thing, Minha, thank you. While Denis is one of my go-to experts, I know better than to listen to only one expert. So he put a YouTube video about Andrew Nigg, how he goes through research papers. So I think listen to Denis, rewatch this episode, watch Andrew Nigg on going through research paper too. So thank you for that, Minha. And I am done. Thanks, Craig.
Yeah, sure. There are 1 million. There's many ways to read a paper. There's as many people that are on the planet. Each person can have his understanding. If I'm explaining like to a 6-year-old person living in Cameroon, I'm not going to explain it the way I just did here. I'm going to take things in everyday life. And I'm saying, if you're playing sports, for example, is it easier to play soccer with one player or 10 players running right behind each other, or to have 10 players running like in a football game all against the other team? There are millions of ways of explaining this stuff.
I see also Mina has another one. the three-pass approach. This one I've also learned about before. A couple months ago, I did issue a post on LinkedIn about this one. So thank you for this reference, Mina. It's a quite interesting read that tells people how to ingest this information. With that, I'm going with Manpreet. You have a question on the side, but I would love for you to ask it to Denis, if you don't mind.
Yeah, so my question is, Dennis, that during my thesis, my
You got muted, Manpreet.
sorry. So during my thesis work, my prof told me to explain the mathematical equations to the diagram present in the paper. So how do you approach this? How do you explain it? How would you picturize it? What goes into your mind? Because when you read a paper, there are a lot of mathematical equations written in it. So how should one approach it and do it?
Well, but you take that equation, Q times K divided by D model and equals V. You just take it apart. What you have to do is, like, you can take only one variable. You can say, what would happen if, I don't know, I have Manpreet, I have to produce the word Manpreet. Let me see how to explain that. To explain math first, I won't use math. I would start with another example. I would say, for example, okay, I'm sitting here and I have to go 10 miles. Okay, so I've gone 2 miles. Let me see. Let me find a better example. That's not a good one. Let's see. Let's take my cat. Okay, I've learned a lot from my cat. I have had a lot of cats, and I've done a lot of AI watching cats. So take a cat. Okay, a cat gets up and he goes near a door. He goes near a door, and then you open the door. Sometimes the cat won't walk out. The cat will just stand there, and you say, I opened the door. Can you go in or out? I'm not your doorman. And you can see the cat is thinking, because it might be raining outside. So he's thinking, I'm going to wet my paws and all that. So what it's doing is it accumulating a lot of parameters. The cat's accumulating a lot of parameters. So let's call all those parameters he's piling up keys, okay? It's the key to him going outside. So you have this cat that wants to go outside, and he's piling up all these keys. It's a bit wet. I'm putting my paws. It's raining. Oh, I see that bad dog over there. So he's piling up all these parameters, okay? And he's saying, gee whiz, when is he going to go outside? At the same time, you can see he's querying, he's wearing. So you have the Q, okay, so of this attention head. He's querying all these parameters, all these keys. He's going through, is it wet? That so he's doing a weight comparison with all these keys. I'm querying if it's too wet. I'm querying if the dog is too dangerous. I'm querying it's all that. And then this cat does it because all this, we invent nothing. Everything comes from prehistoric times. You may not know that, but we didn't invent a new brain this year, So the cat does that, and he says, okay, I'm querying all these parameters, all these keys, which is what exactly the attention head does, and it equals a value. Now that value for me is am I going to go outside? So now he has all these parameters as well in his values. And since it's too complicated, he's just going to divide it by, all these features and say, okay, I'm going outside or I'm not going outside. So you can see that you reason like that too. You're saying, I'm working in this company. I'm going to query myself to see if I'm going to another company. And you take all these parameters, those are the keys, and then equals these values. So now you have this equation, but what we don't have is the value of those parameters. So we know what to do. We have a query. We're going to multiply it by the key. It's going to equal the values, but we're going to divide the Q time by something, but we don't know those weights. So what we do is we ask the transformer to use classical gradient descent or whatever it wants to find those weights. So basically what we're saying is we're at the door with a cat. We put a cat there, and we say, his brain is empty, but I'm going to put a little computer simulation on it, and it's going to run all the parameters, the combinations of parameters, until we find something that's pretty good that matches the weather outside and everything. So now that you have all these images, you have to teach your students how to relate this to their everyday life. Like Tom is eating all the time since the beginning of this meeting. So, and he's drinking now. So we have, Tom is in this frenzy here. So he's querying his hunger and his thirst, and he's looking at all these parameters. How many cookies did I eat? How much candy? How much stuff? And then there's going to equal a value where you're going to say, hey, this is enough, because if I continue like that, next time they won't see me on the screen. Okay, so, but then the machine has to find the parameters, since it's an empty brain. There's nothing in there. There's no intelligence. There's nothing. So we have to run all these probabilities, all these things until we find a good weight. And then since we find it for the cat, now those same parameters have to work for a dog. They have to work for a human being. They have to work for everything we put in there. So now we have a common set of weights that will work for a lot of situations like that. And in fact, you can compare the cat thing to someone going out of a company into another company. Now, what I'm saying is very important for the next questions Greg is going to ask. So I can use this cat thing to say, the queries, I'm going outside, the keys are this. Okay, the value, I can use this if I'm going out of a company into another company. I can use this to go from one word to another. I can use this to go from one sound to another. I can use it to go to one pixel to another. So in fact, every time you have, imagine this little cat sitting there, or a rat, it can be a rat, but people don't like rats. So I'm using a cat. So it's something we do every day, but we do it with intelligence. And machines do it with no intelligence whatsoever. They just do it random. Most of gradient descent is stochastic now. So it's, just finding something until it works, okay? So basically, it can apply to every situation in life where you're somewhere and you have to go somewhere else. You're querying that somewhere else. You have all your keys. It gives you a value. You have this relationship. You take it down with demodel the features, you divide it so it can be, a little, get smaller numbers. That's about all there is to transformers.
Thank you for that answer, Denis. Manpreet, if you have anything, it looks like I see your head is shaking like this, so it sounds like you're satisfied with the answer. With that, I'm going to move on to Rife. Thank you for your patience. So I'm eager to hear what, yeah.
Thank you, Greg. Thank you, Denis, for this example about the article. Now, regardless the John Nash lighting words, okay, methodology that you follow, okay, not everyone is able to catch the keywords in 1 second, but okay, this is good. But what I understand from this, that you are always starting from having a general understanding, let's say a zoom out image about what we are going to face, and then step by step you are going deeper and deeper, and this deeper can, let's consider a zoom in, that you are focusing on some concept until you reach to the point that you understand everything. Just you like you are using the telescope, you get the sky image, and then you go for a specific object there. Now, I like this methodology in general, even, okay, maybe it's not easy to be generalized always, but yes, if always it's very useful from my point of view to have general understanding about what you are going to face, either it's article, book, business case, whatever, and then go deeper and deeper. And when you have a time, it will be very efficient, because with time, everything will be, I don't know, just like bread waiting. That means it will be better and better. Now, my question here, it's when you are moving from reading, understanding to practicing. What's motivate you to practice? Now, not when I think it's not a good question, but what motivates you to start practicing something that's considered new or revolutionary? This is my question.
Okay, so what motivates me is it's like you disappeared, this guy disappeared, but you're here again in the next square.
I'm here.
Okay. So I just want to say something first. What I'm doing here, let's go back to a cat. Okay. Now you take your cat. Let's stay with our cat. The cat now is a mountain cat. It's not your domestic cat anymore. He's in the mountains. And when the cat is scanning around him, the cat is not going to zoom into every bush, into everything. It's just going to see where there's movement. It's going to scan around and it's going to see movement. And if it sees a change, then that's what we do with keywords, because we're looking the abstract into a bush. And what we call keywords is something that stands out. And it comes from our ancient reflexes. When we had to survive, we couldn't spend time, observing the little fly. No, we had to find, oh, that's danger. So now I'm focusing. So keyword comes from a sense of danger. Then I'm going back to my cat, because cats like to play around with the mouse. You can say, once I'm finished reading the article, why would I even bother practice? I mean, I understood the thing. Okay, it works, it doesn't work. But I like to play around with it. And I like to sadistically take it apart, exactly like a cat. I like to find what's wrong with it and crash it. So I know, for example, that Google Translate works with BERT, and BERT with a very powerful version of BERT, exactly like almost like GPT-3 about. And I just love to go into Google Translate, for example, and crash it. So I'm going to find all the exceptions. So my approach to practicing is sadistic, is looking for what's not going to work. And once it doesn't work, I'm looking how to fix it. And now, as I go through this, then I'm understanding I need to understand everything in the system to find out how to fix it. So now it's like taking a toy, and before playing with it, you all take it all apart, and then you try to build it again. Or sometimes I'll just play around with the toy. So I would say fun is my motivation. This is why I always like to program, because I like to play around with the mechanics of it. I like to crash it. I like to find the errors. It's full of errors. You find errors everywhere. It's fun. And then I just like it. I just like algorithms. It's fun. It's like playing chess. For me, development is fun. So it has never been work for me. It's something fun. So I'm telling you, it's like everyone. I'm just like a 6-year-old. I just like to play with toys.
Can I also maybe interpret why you're motivated by that, Denis? And you can correct me if I'm wrong. But from when I hear you speak, what I hear is someone who's passionate about discovering how machines can understand living beings' behavior or this world's behaviors. So kind of like, you have fun. You have you like to break those things apart in the machine or in the system to kind of understand how well it can understand our palpable world. So when it comes to a cat deciding to go out there based on a set of keywords, or me trying to evaluate whether I should stay in my company versus going to another company, you like to build that bridge and understand how this machine can learn us, or can learn this planet, can learn this living space.
Since you mentioned, sorry, just a minute. Since you mentioned that this was something that I was thinking about, maybe here with this multi-head attention, with all of these blocks, we understand something about how artificially we can make the evaluation of the status. But personally, I'm still, let's say, it's not clear for me at all how I'm making my own decision. In general, how the human makes their own decisions, how they are moving, what is the attention for them, let's say.
Yes.
Personally, it's not parametric at all.
Yes.
At least, even if it's parametric, it's not measured. Okay, this is something else. Now, this is sorry. Thank you, Denis. It's really I enjoyed your answer. Thank you very much.
Go back to what Greg said. I'm full of anxiety because I realize that our life is very short. I realize that by the time you understand you're alive, 10 years have gone by. Then you reach 30, hey, you reach 30, did I do everything I want? Then you reach 40. So I'm very metaphysical. All this worries me, and I don't understand the world. I don't know why I'm here. I don't know where I'm going. I'm spiritual like Gayeth. We share this, but it's still in the end we say maybe I'm wrong. Maybe. So I'm very worried about why I was born, what we're all doing here. And then the reactions of all human beings, especially mistakes. Like I'm watching someone thinking for 2 days and he comes up very happily and it's an incredible mistake. So this puzzled me when I was a child. So I'm always trying to figure out what is the reasoning of the person, whether it's good or bad. Now, machine, if you go into my profile on LinkedIn, there's just one thing I'd like to correct you. My first principle in artificial intelligence is anything that artificial intelligence can replace you with is not the essence of a human being. That goes to what you were thinking. That's not our essence. Our essence is not a bunch of parameters. Our essence is love. Our essence is belief. Our essence is courage. Our essence is being happy with people. That's our essence. Our essence is not playing chess. Our essence is not doing math. That's my essence. Later in this evening, my son has come over with the woman she's living with. I have my nephew with just someone he just met. I have another nephew who is crippled, and my wife, we're going to all go eat pizza together. That's the essence of life. So the first thing is, I'm not looking at all for intelligence and artificial intelligence. In fact, if I go back in time, I would say that these dumb idiots in 1956, if they just could have said machine intelligence and leave us alone with this artificial intelligence, and go back to Turing in 1950, who wrote Machine Intelligence. And he said, unfortunately, it hasn't happened. He said, it's so obvious that this is just mathematics that in 50, 70 years, no one will ask the question. But it's Frankenstein. Who would want a computer to wake up with consciousness? Imagine the nightmare. Tomorrow morning, I wake up and I'm silicone. And I have all these. So we need to separate this. It's a tool. It's just a tool. It's a fantastic tool, but it's not our essence. Now you have the opposite principle I put in the second sentence to my profile. Anything that is the essence of machines, well, it's not the essence of humans either, because machines have their own essence. Transformers have their own probabilistic essence, which is fine as a tool, but I'm not a transhumanist. I don't want Elon Musk to put stuff in my brain to be smarter. I don't want to be smarter. I want to be loved. I want to love people. I don't want to be intelligent. I want people to love me, and I want to love other people. And I don't want machines to be transhuman either, be trans machines. So machines are tools. We're there. And I just love to play with the mechanics of all that. That's all. It's just playing with toys.
That explains a lot. I appreciate the clarification. At the end of the day, I think we all feel this way, where we're evaluating our why. Why are we here? Are we meant to do something big? And, but I don't like to dwell on it so much when time still goes by. While I sit here wondering, am I meant to do something? I have my wife, I have my kids, and that little moment that I can spend with them means so much more than anything else. It has no price.
Wife and my kids.
Yeah.
What else do you need in life, my friend?
Yeah.
You don't need anything. You have it all. and spend even more time with them. Spend less time with people like me and more time with people like your wife and kids. I mean, it's so important.
Very good, very good.
I'm not
Hugo,
saying I'm not saying it has to be with a woman. It can be two men. It can be a man with transgender. It can be two lesbians. I don't care. Two transgenders. What I'm saying is people together. I'm not saying I'm not looking at the nuclear family. I have
yeah,
friend. In fact, I have a transgender friend who is now a woman and living with a woman. And every time I speak to this person, it's like 360 degrees. I'm learning something. I'm learning
yeah,
something. I'm learning a lot. So I'm just saying love. That's the key word. You know, at the end of the day, love. And you'll
yeah.
never find it in a machine. Or
Understood. Yeah, it's about really human to human interaction, and with that word, I think love sums it up pretty well. With that, Hugo, thank you for your patience, and I'd love
thank
to
you.
hear what you have in store for us.
Yeah, brother Greg. Hi.
Hello.
Okay, great. Dennis, thank you. So there are a lot of questions that come to the mind, especially I've been consuming a lot of Dennis Rothman, the articles. And I must say too much Dennis Rothman sometimes can do something to your thinking. So so yeah, it's been like a source of concern for me. There are a lot of questions that I began to ask. First, I asked things like, oh, first, Dennis, let me remind you, you owe me and all of us a video session, trainings on transformers. You know you're going to do that for us, yeah?
Yeah, of course. We can organize something like that. You can organize it.
Okay.
And I'll follow you.
Okay, great. Right, great. This is good. Okay, so first things first, I wanted to lay my hands on and try to play around with GPT-3, but I learned to open AI, and their name is Open AI. He's not releasing it yet to the open. So I'm wondering what that means. And but I learned another organization that's this guy is behind Elitha AI. They're trying to work on something called GPTJ to open source that transformer that technology. So for me, my question has been, right now, natural language processing can generate low-level codes. I mean, I saw some of the things that were generated by the GPT-3 and the GPTJ. And so I now begin to ask, where does data science head to from here? Because right now it seems a lot of things about data science and machine learning is just around neural networks, model.fit, model.predict. Now that machines can actually do model.fit and model.predict and generate all of the codes and all those awesome things that we do, where does it take us from here? Now, are we going to become dinosaurs? Are we going to see like what happened in the was it now the third industrial revolution that caused a lot of, well, I know people have been saying there won't be job losses and all that, but again, the terrain is real. Now, with the pace of development that the GPT-3 and GPT-J are picking up right now, most likely we think that it will be ready by next year, I think. I don't know, but by next year, I think it should be ready for general availability. Now, if that is deployed, general availability, and the whole acceptance thing is amazing, it means that we have just 1 year to just be our regular model.fit data scientist. So in this 1 year, where can we head to? What can we turn towards? That's just the first question. I would like you to attend to this, then I would just ask you like one or two more, and I would allow others to ask.
Let me put this one together. Now, let's take the city of Florence in Italy. around the Renaissance. You're at the end of the big wars in Europe with fortresses, because now we can break down fortresses very easy with cannons. And we're in the beginning of more finance. And so we go from Middle Ages to Renaissance. But many people lived like in the Middle Ages for centuries after. They didn't know the cities, they didn't know what was going on. So what I'm saying is eras overlap. It's not this year, it's this, we enter a new era, but they overlap. When cars replaced horses, people laughed at cars. And the horses were there for a very, very long time, for years and years, until cars took over the horses. When you go to the 1980s, I'm fast forwarding, so we don't say stick in prehistoric times like I do all the time. So, but we could do that. So in the 1980s, I've seen this already. I saw personal computers appear, and the older generation was working on servers, and they were working with COBOL, and I was starting to work with C++. And I was saying, you know, pretty soon I'm going to be able to do what you're doing on your very costly server with my little PC here, and you're going to be wiped, your department's going to be wiped out. And he tell me mainframes will never disappear, you know, so, but it disappeared, okay? They disappeared. Now, you have, from 1980s, you have two generations, COBOL, and you know that you still have COBOL developers today that are pay $100,000 a year because there are millions of lines of code and no one's managed to translate them all. But they're dinosaurs. If you talk to them, it's like talking, you know, like talking to someone in the 1960s. But he has a job. He has $100,000. He probably has a nice house, a nice car. He doesn't even care about our conversation. He doesn't even know what artificial intelligence is, and he doesn't care. He plays golf. He's probably a grandfather like I am. What does he care? You know, so what I'm saying is you don't have to worry that much. So now let's fast forward to today. Today, 99.99% of the mainstream population thinks we're in the digital revolution. COVID, we're digitalized and Zoom. No, that's 1996. And it stopped around the 2015. We're in the fourth industrial revolution. And it's not a question of losing jobs. It's a question there's too many transactions. Supply chains have become so huge in the world that no one can do it anymore with old ways. Google has 2.5 million servers, probably more. It's impossible to do it with classical software and classical AI. You need some special AI. So you needed transformers. Then we get to GPT-3. GPT-3 is not deep learning. GPT-3 is post-deep learning. It's a foundation model. It's something totally new. And there's this 212-page article written by 100 scientists at Stanford. Everything happened this summer, very quickly, July, August, bam. Okay, July, August, Codex comes along with the GPT-3 programming that can replace a lot of programming. And August, Stanford comes along with this article saying, hey guys, game over. This is not deep learning. These are foundation models. And they're kicking academia out of the game. We're not in the game anymore. Our universities are kicked out. These big tech companies are taking supercomputers at full speed. No one can catch up with those budgets. You can try open source all you want. You'll never reach billions of parameters on supercomputers. It would take you years. So they just put everyone out of the game all of a sudden in July, August. I even wondered if it wasn't on purpose. No one even noticed it. So we're all out of the game, actually. So now you go to GPT-3. It's far from being AGI. It will never be AGI, and it won't be next year. It won't be the year after, and it won't be in 10 years because you need funding. But that doesn't mean it can be very efficient. You know, you can take an ATM machine, you know, the machines where you take your money out. There's not much intelligence in there, but when I was young, there was a person there. You actually had to go to a cash window and ask for money. So you don't need much intelligence to replace humans because humans are not that intelligent. The work we do is not that intelligent. So a GPT-3 model can do a lot of very simple things that we don't have time to do and not even replace us. That's why you don't need to worry that much. It won't replace us. It's first going to do a lot of things we don't do. Google search is run by a foundation model. Google BERT is mind-blowing. We could never train it on a computer, and it does all the Google search now. I wrote a post on that one, and I gave you the blog. So foundation model is exactly the cat situation, where you just have one model, and it can do everything. It can do everything we need it to do in a supply chain. I don't need it to love. I don't need it to have consciousness. I just need it to go to Amazon and predict what the next pier in that warehouse is where that truck has to come. It just has to do these kind of things, and you'll earn billions with it. So data scientists don't have to worry because CEOs, you have to go back to Industry 4.0, don't understand Industry 4.0, which is machine-to-machine communication to speed up the supply chain. And there was this study by McKinsey or Gartner saying the CEOs don't even understand Industry 4.0, and transformers are a heritage. They inherit from Industry 4.0 because we need machine-to-machine communication. I don't see any job losses. That's what puzzles me when I read all these LinkedIn articles. I don't see small companies needing GPT-3. So I think it will be like cars. It's going to last for many years. But here's a problem. If you're working in a big corporation and you have a consultant like me around, I'm going to say, don't bother with an AI project. Just go to Cloud AI, Amazon, Google, OpenAI, create an account, and we can do, let's say, 60% of what you want with absolutely no one. And you don't need a developer. We can start with prompt engineering. You go to Codex and you learn how to create a web page with buttons. I'll tell you a secret. My 12-year-old grandson created a part of a website in 10 minutes and deployed it on his little application he's putting online. So, and he didn't even know what he's doing. He said, that's something I couldn't do, and I just did it. So Codex is extremely powerful, but it won't replace you. It'll just accelerate. So in the year to come, if you want to stay in the game, it's up here. It's up here where you have to understand transformers. You have to realize the power of supercomputers. You have to go into Google, because Google GPT-3 was trained on a supercomputer which was 50 petaflops. But Google found something incredible, is they created their own domain-specific chips that don't use all the floating points we use for calculations, and they have 100 petaflops with a very cheap supercomputer. So, well, cheap for them, not for us. You know, it's like $17,000 a year if we want to rent it. So I'd say in the year to come, my favorite topic, and Tom knows it, is philosophy. Learn all the concepts you can, and play around. If you can sign up, play around with GPT-3. And you know what? If you can't sign up, play around with Google search. Google search is run by a foundation model. Try all sorts of things and see how it reacts, and learn how. My son likes to play a game like that, although he's not interested in what I'm doing. He's in IT, but as a project manager, and he's not interested in my topics except when we eat. He doesn't want to learn about GPT-3 and all that. But he likes to play a game on internet, is how fast he can reach an article, or how fast he can reach exactly the subject he wants by typing something he wants. And I say, wow, that's incredible. He says, this is fun. So you can try that with this Google BERT thing. You can try GPT-3. You can try Codex if you can get on it. And I would say just, concepts, read all my posts, learn them, read the books, get the concepts, because that's the main thing. Because by the time you learn those concepts, you might be in another model already. So the main thing is what I showed you in the article, high level, and then learn everything you can as fast as possible and get ready for the next step. That's how I survived, my friend, from 1978 to today and still being on the cutting edge. Otherwise, I would have been an old timer years ago.
Right, right.
I
Thank you,
appreciate
Denis.
I appreciate the answer, Dennis. And Ugo, before we come back to you, I would love to give Amar a chance to ask his question, and then we can kind of circle back around. So just to give everybody an equal playing field. Go ahead, Amar.
Thanks, Greg. Thank you, Ugo. And hello for everyone, Valerie, Grace, Thomas, Kimberly, everyone else. Dennis, I have actually like some sort of other interpretation of what Greg interpreted regarding Grace's question. It was about when to start practicing after reading some article that introduces a new concept or something like this. So you said that you read the paper, you understand it, and then you go to application for following some sort of feature that clicks in that you need to apply it now. I actually think that it is more convenient to think of it as a deeper level of understanding, meaning that when you daydream it and you wake up the second day, you didn't understand something new. You understood it better. Because when we talk about, for example, let's say linear regression, we can introduce it in like a minute of talking now, and we can talk of it in like 2 hours of deep math and calculations. Both are understanding, but one is deeper. So do you think that this practice level is for deeper understanding, meaning that when you get to the source code and start playing with things and try different combinations and stuff, and you investigate when and how and why it does crack, and for example, your grandson or your son who searches on Google and looks for different times for the same search, is he maybe he understands already the Google search engine, but he needs to practice it somehow to get a deeper understanding? Is practice a deeper understanding level, or is it something, or it's like a complete different thing?
That's a very tough question because you guys take me out of my my comfort zone. I think I'm gonna say something I maybe shouldn't say, but I don't think anyone can do anything in artificial intelligence without linguistics. So that's why I'm always very careful it's no use practicing anything especially in NLP, if you don't know linguistics. So that's the problem I see on LinkedIn when people say, I got my GPT-3 account and I went to Codex and I typed something, it doesn't work. I say, yeah, sure. Go to China and speak English. Or go to Japan and speak English, or go to Kenya, and instead of speaking Swahili, why don't you speak Chinese? To talk to an artificial intelligence program, you're talking to an artificial system of thinking. So you're in semantics. This is what I call the meta language. And this could apply to CNNs, to anything you want. It's how are you going to communicate with it? How do you communicate with that algorithm? Your input is a way, but you need to know the language. I'll give you an example. I wrote a program 30 years ago that optimized fabric in corporations, and I was paid on the money it saved. And one day I went to see this woman who was just a worker and using it, and I say, wow, what are you doing with my software? I didn't know it could do that. And she said, yeah, but I've been doing my job all my life, so I know what I'm looking for. So I'm looking for that in your software, so I find a way. So you can't go into GPT-3 if you don't master linguistics. Do you know your grammar? I mean, school grammar. Do you know high school grammar? Do you know vocabulary? Do you know what a lexical field is? Do you know what polysemy is? Do you know what a synonym really is? Do you know what definitions of word? Really, linguistics, not in the sense of learning a language, but of understanding the mechanics of the language. Once you have that, there's a big gap between the theory and the practice, is that meta language. What am I asking of linear regression, for example? What do I expect of linear regression? People will say, well, linear regression doesn't work because you take all these points and you put them together. Okay, suppose I want to speak linear regression, and Tom is an expert in that field. Maybe I don't want to put all the data set in there. Maybe I'll just take some points, make a linear regression, take some other points, make another linear regression, take some other points, and now I have 10 linear regressions on the same data set. And now I have 10 different features of it. And then I might want to group it all in a k-means clustering thing and see what happens. What I'm saying is, if you don't speak the language of the machines, you have no chance of getting anywhere. And you will see people piling up lines and lines and lines of code and algorithms where I said, you know what? You spent 2 weeks on that. I can do it with an Excel formula in 5 minutes. So what I'm saying here is there's a huge gap between theory and practice, is linguistics in the sense of semantics and understanding the algorithms in form of a language. Mathematics is only a language. It's just another language. You have Japanese, mathematics, Chinese. Mathematics is a language. So once you have that language, well, you need to learn that language to speak to that person. So when I go to practice, that's why I say I'm sadistic, because I know how to speak the language of Google Translate, because I've written translation programs. So
And
I speak the language.
And
Real-
in the
real
same
quick.
time, this meta formula is hard to get into because it's non-expressible. You cannot express it anyhow. So you go into practice in order to get some intuition out of the practice and fill this gap behind.
It's let's say something. We're both 10 years old and we both get a chessboard for our birthday. We're both 10 years old and we get a chessboard. And in, let's say, 2 or 3 months, our parents have taught us how to move the pieces. Then what happens? Well, goodbye. You have those who have the vision, who understand the language of chess, and those will struggle all their life because they don't understand the language of chess. Chess is a language too. It's something. It's something very visual. Chess is a visual language that comes from battlefields, that comes from hunting in the Paleolithic days. So when I learned chess, I didn't see squares. I saw a lot of fighting and knights hiding and all that stuff. So it's talent, my friend. It's called talent. Talent is not, you can cultivate it, but if you don't have talent, you don't have to worry about it, because there's something called teams, where in the same team, you can go see someone that has that talent. You don't have to have that talent. You don't even need to know artificial intelligence if you have someone around you.
Now, just a quick safety check. We all agree that we love Denis, and we like it when he gets to come out to play with us. But are we getting in trouble with Catherine right now? Or are we safe today?
Yeah, I have a 7:30 to 20 to 8 curfew.
Excellent. Just making sure.
20 minutes to get to the pizzeria where we're eating the pizza.
We can't afford to get on Catherine's bad side. So
I love to joke that with her like that.
Yeah, that's
my nephew saw me go down, and he said, "Why don't you go down someday and show them the soup that Catherine makes?"
Yeah, thanks for that checkup, Tom. It definitely good to check
I'm
now.
okay until 7:30 or 7:45, unless you want me to stop before, of course.
Oh, I think we have much more things that we'd love to explore. So I'm all for exploring your brain, exploring each other's brain. as much as possible. So, Ugo, you had some follow-up questions that I'd like to hear from. So let's circle back with you.
Thank you, Greg. Okay, so Dennis, the second thing I want to ask is this. Right now, we know that one of the barriers to entry into this GPT world is the compute resource that's required, because it seems like right now it's only big tech that can provide us with this compute resource, and they will gladly provide it at a price tag, either with the IaaS as infrastructure as a service or some other method of deploying. So what that means is that is it possible that this thing can become open source tomorrow from what you see?
No.
Will the technology, it won't be open source?
No, it'll never be open source. We've changed eras. We're in industry 4.0. It means fierce competition, machine-to-machine intelligence, and there's inequity. We've gone from a democratic world of GitHub with open source to an elite world where you have big tech that is flying very high in power, turnover. They're not going to share anything. You have Amazon, for example, web service, they're not going to share anything. In fact, many people don't even know what's going on in Blue Origin. You know Blue Origin?
Yeah.
Yeah. He's trying to catch up with Elon Musk. Even the employees cannot even say a word out of the company. You see, they're on LinkedIn and they never write anything. You just see them put a post on with no comment. Nothing can come out. OpenAI is $1 billion research place. And where is it going? To Microsoft Azure. It's Microsoft. Microsoft is behind there, picking it all up. They're not going to share it. They're going to sell it. Why would I give you something I can sell and make myself even a bigger billionaire? Okay, so then you have Google is certainly not going to open source it, but they're giving you a little carrot. They're saying, yes, 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 we're not going to open source it. But if you come to our cloud AI with our domain-specific supercomputer, you can rent it only for a few $100s an hour, our supercomputer. And if your company $17,000 a year, what is that compared to a $10 million supercomputer? So you have this little bait saying, oh, yes, Ugo, come to Google. We'll let you train something. It's going to cost you $17,000 a year. And since you can't do it by yourself, well, you might need a consultant, or you're going to waste a lot of time on our cloud AI platform. And who gets all the money? We're going into an elite world where big tech has taken off without us. And there's going to be, and it's exactly what happened in the 1980s. I saw the AI winter begin for academia, everyone, and I saw AI continue in the military, aircraft, everything. It never stopped, in fact. So now we're just going into an elite world. But what does this have to do with you? You don't care. You're trying to learn the mechanics of it. So in fact, you can use anything you want to understand it. And once you understand it, if someone gives you the opportunity to use GPT-3, well, you know that you can train on GPT-3 for maybe $100. It will cost you $100. They gave me $18 in June. I still haven't managed to use all those $18. So if you ever get an account, just play around with GPT-3. You have the API. You can go to Codex. Codex is free right now for the moment, but just learn how to use it, because it's not going to be about development. They're going to come up with even a more powerful foundation model, which is training won't be even required anymore, or I don't know what they're going to do. But it's not going to be a democratic world. We're definitely going into an elite, and this elite is not going to slow down. It's going to keep going, and they're going to push us down like into low level.
With that, Denis, I hope Denis was able to answer your question, Ugo, and I do have a follow-up question to that, if you don't mind.
When you're done, I'll come back. When you're done.
Yeah. So what does it mean for the global economy? You've given us a glimpse on what it means for people with regards to keeping their jobs and not losing their jobs. Do you see these foundational models push new startups? Can startups now become unicorns with these foundational models, GPT-3 or Google's infrastructure? Can they rely on these structures if they want to call themselves, AI infused or AI based products? Are we saying that forever we'll see these big players remain big players forever, or can some startups build on them? Because the way I see these systems is kind of like the transportation world, right? Where the transportation world allowed a lot of companies grow their supply chain, or the internet created giant companies that we know today. So these foundational models are certainly going to push the economy in certain ways. And where do you see these startups with these foundational models?
Well, there's a lot of business, because as long as someone, like, suppose I wanted to open a business to do that, I would go maybe to OpenAI. I would sign up, I would create APIs, and then I would tell customers, you know what, do you speak the meta language of GPT-3? Well, I don't think so. So you can sell applications that you're going to develop 10 times faster, but you might just sell 70% less than before. Suppose I was selling something $10,000, and now I can do it for $1,000. I'll still sell it for $6,000. I can make a lot of money. So money is something, someone with talent will always make money with anything. Even talking about GPT-3, a consultant can go for $1,500 a day to a corporation and just talk about it. So I think it's two separate things. Foundation models are just another commodity, and the entrepreneurs that can do it will do it like they always do. It won't change. These foundation models won't change anything on the global market except add a component that's very practical. It's just something there that you can sell, buy. It's a commodity. It's like when phones came along, or smartphones. That's not what I'm worried about. What I'm worried about is, what worries me is, since you're getting into my brain, is climate change and the lack of resources on this planet. Because as we speak, I don't know if you know about this global day in the year where we consume everything of the planet, like in August. Okay, a country like Switzerland does it in February. Canada is February, March. So I'm worried that we're destroying our planet, and at the other end, we're speeding up the means to consume even faster. So I'm saying, Denis, you're eating too much. You just put on 20 pounds. But you know what? I found a way for you to eat even faster. So I'm a bit worried about that. And I can see that at the same time, renewable energy is just exponential. It's going at full speed. But I'm wondering who's going to win the game, because I never saw what I saw in Manhattan. I never saw subways full of water, or basement apartments full of water, or New Jersey with tornadoes. I never saw fire tornadoes in California. And I've never even seen a storm like I just got here, which cut all the internet off in 5 minutes before the meeting. I've never seen stuff like that. The rivers here are so high, I've never seen it. I'm in a place where water was missing, where the rivers were so low, you just had that much in some of the rivers, and all of a sudden you can't even cross them. So I'm worried that we're doing good things. I mean, green is going very fast, and everyone's trying to do things, but at the same time, we're going in faster with other things. So are we going too fast? That's my question. Should we slow down? I don't know, because at the same time, for medication, it's very good for people to have found vaccines faster. Otherwise, we might all be dead. So it's just a philosophical question that worries me. It just worries me that we're creating tools that are just so powerful. I don't know where they're going. So, but in the end, I'll have a nice glass of wine with some pizza. It won't worry me all that much.
Fair enough. Thank you, Ugo.
And chocolates, Dennis. You didn't
Oh,
mention
and
chocolates.
Chocolate,
Yes.
yes.
Every day. Chocolate every day. No
Right.
chocolate, no life.
Okay, so for me, Dennis, one of my major worries is this. Will the data science department of the future be divided into two? Like, okay, there are two tiers, where the first tier are the big companies that have access to funds. So they run on all of those GPT and co. And the second tier will be like for companies that do not have all the funds, so they remain with CNNs and RNNs and all that. Or would there be like a middle tier that would try to marry these two together? And that's when we talk about democratization. But since you have ruled out democratization, does it mean that these are the two parallels that will run over the next 10 years or something? Or do you see anything changing?
I see AI like in the army, like foundation models and all that. Those are the special forces. And then the rest is just a regular army. And I think that companies will have to integrate the cost if it's necessary for them, even if it's a small company. They will have to integrate the cost of using Google AI. They will have like a feed, that they pay every month, into their arm to pay, just like, organized crime. So you're gonna have to, organized crime is organized in the same way, where they just pump money out of you every month, and then you can survive on the market. So I don't believe, that's another of my beliefs. I don't believe in democracy as for everyone. I believe that in any country in the world, if you're rich, you're free. In any country in the world, I can get a passport in the United States. I can give you a passport. But if you live somewhere in Ohio where you don't have water, because there's about 1.5 million people in the United States don't have water or electricity, I'll come up to the guy and say, here's your passport. You're free. You're not like in China. You can travel around the world. Hey, go to Paris next. No. So I believe that democracy is good for people that have money, and that for people that don't have money, well, democracy, they don't understand the word. And that's why we have all these conflicts that are growing in Western civilization between people that, live in cities, go to college, have all that money. And then we look at TV, why are these guys rioting? We have like the yellow jackets in France. They're every Saturday, they're protesting. And we say, why are they protesting? The guy says, yeah, well, give me some food for gas. I don't know. So I believe that AI is going to go up and up. It's going to be powerful. Those who have a lot of money will do a lot of good things with it. Just like it's been like this since the hunting days. If I were a hunter and I knew how to do some silex very well, and I went hunting and I brought back an animal, you think I'm going to share it with everyone? No, I'm going to eat first. Then my family's going to eat. And then I'll give the rest of it to these people that didn't go hunting. What's changed in 100,000 years? I don't know. Not much.
With that, I think you've approached the deadline of 1:30, and I'm so glad you were able to give us a good bit of your brain. I'm pretty sure we haven't scratched the surface. I've enjoyed listening to other people's starts, Amar, Life, Ugo, Tom. I would like to thank you on behalf of everyone for your time. This has been one of my...
Yeah, I still have, the questions never end. So yeah.
Let me answer another of your questions. I don't like, because I read you a lot on LinkedIn too. I loved your post on the LinkedIn police. That's genius.
All right.
Because I saw LinkedIn police. I thought it really existed first. I thought, wow, there's a LinkedIn police. So I'm saying, then I read it, and it was so brave to write that. I would never even dare write something like that.
Right.
I love that post, the LinkedIn.
Yeah, and the post fetched me a lot of rebuke from a lot of friends and a lot of people. So I eventually had to tone it down. Yeah, but a lot of people were concerned about it. So it wasn't like natural me. Some people just got on my nerves, and I just felt
LinkedIn police. So what is your question?
Okay, yeah. So maybe I should make this the final one so I could release you.
Yeah.
If someone asks you to describe the data sciences of Industry 4.0, his skill sets, his tool sets, what would you describe it as?
Well, that's very simple because I've hired a lot of people in my life, and I was Industry 4.0. I've been working in supply chain along. Very simple for me. The first quality is to understand the job. I mean, not our job, the job of the company. Let's say I'm working in a company that's manufacturing screwdrivers. I want that data scientist to spend a month in the workshops. I want them to learn how these screwdrivers are manufactured, talk to the people, eat with them, go with them. I don't even want to see him in his office. He has to be in the workshops. And I've done this with my employees. I said, listen, you know what? You're going straight to Air France. You're going to spend some time over there looking at maintenance, talking to people, to understand the job they're in. If they understand the job they're in, they'll understand the data that comes out of it. Once they understand the data that comes out of it, then they can see the keys, like we were speaking about earlier. They can see the key data and they can pick it. So the main thing is to have pragmatic and practical knowledge of the data, of the world that's behind the data, and then to be able to identify the best things that represent that world, and then to apply them. And you can notice it has nothing to do with artificial intelligence or even computer science. This is why people like you, Ugo, will have a job for 100 years, because it's not technology. Technology is something you can learn or use. And if you work in a team, you can go training. But what I'm talking about here, that's the main thing. You're talking to people. So, and that's how I always did it. One of my first programs, I probably told you this already. I took my computer, I went to a textile company, and I installed my computer in the workshop, full of noise. And over the months, I did the job of every person. I did the cutting. I went to the dyeing department. I knew every job. In fact, I could have worked as a worker in most of the departments after a year or two. Then my program, of course, reflected it. So you can see what makes a data scientist is understanding where the data come from. So you can say, oh, that's the situation. That's the data. Of course, I can represent it. I know what they're thinking and what they need. You can use Excel. You can use a piece of paper. You can do anything you want. You can do transformers, linear regression, CNNs. It doesn't matter because you'll find a way to do it. And I can give you a good example. Take an artist like Leonardo da Vinci, okay? And give him just a pencil today, and give us all the painting set we can have for $10,000, all the tubes, all the brushes. Who do you think is going to make the best drawing, him or us? So you don't need that much. Keep that in mind. If you understand the people, the data, you just need a pencil and you'll do 10 times better than even someone comes with GPT-3 in the company said, do you know how to make a screwdriver? Do you know that feature is important? Well, I don't see what I mean.
That's, Thank you.
That's
Thank you very much, Dennis.
That's very enlightening for me too. That's
powerful because it's the same thing, Greg, that Tom has been saying. The basics.
Correct. And
People. people.
Dennis, I'm a firm believer of Gemba. Gemba is a very powerful way. I'm an industrial engineer, and when in Ugo, you can rely on that too with the lean concepts. There is no way you will understand a problem without going out there on the shop floor and seeing it with your eyes and talking to the people who are affecting the process. And that's how you collect the data. That's how you can see the data and see what's important out of that data to prescribe a correction to improve
comes after. You can use any tool after. So, my friends, it's going to be pizza time.
Thank you so much.
No soup tonight. It's only pizza. And well, thank you for giving me the opportunity to get out of my closet sometimes.
Well, certainly I appreciate your time, and it's been one of my wish lists, which happened a day after my birthday. So you gift me with this presence today, and thanks Magdi who put it together, Thomas, Raif, Ugo for your questions, everybody else. I appreciate your presence.
Well, thank you to everyone, and thanks to Tom always for giving us this family feature, bro and son and daughter. I'm not like that, but he's getting to me. That's beginning to worry me. I see myself signing, "Hey, bro, thanks, bro." Tom is getting into my autistic shield, and he's getting behind it.
Well, I should have done this at the beginning today. There are several of you now helping other people as much or more than me. And a big thanks needs to go out to my top Nigerian son, Hugo. Hugo is going way above and beyond helping others. You're a model integrated family son.
He's the LinkedIn president.
Yes.
And Greg, all of you, and Gayeth, you all, I just love you all now. But Tom is really, he's instilled this warmth in there. So have a nice day or evening or morning. And I'll try to get there next week to listen to others. Okay. Bye-bye.
Bye, Dennis.
Bye-bye.
Thank you, team. I appreciate your presence today. And Tom, thank you for giving me the opportunity to lead the meeting. It was quite insightful for me. And I hope that you guys gained as much as I gained today. I've learned as much from Denis as I've learned from your questions and comments. And I appreciate you all.
Take care, everyone.
Bye-bye.
Thanks, everyone. Goodbye.